Loudness is a measure of auditory sensation which is measured in sound. It depends on sound pressure and frequency. Loudness of one sound corresponds to the loudness of pure sinusoidal tone of 1 kHz and with sound pressure of 2 millipascal. And the loudness level is the sound pressure of 1 kHz tone, which is as loud as the sound which is measured in phone. So, loudness N is a psychological concept to describe the magnitude of an auditory sensation, the loudness of a sound measured in sona. Loudness level of a sound is the sound pressure of 1 kHz tone, which is as loud as the sound, and the loudness level Ln of a sound is measured in phone. One phone is equivalent to 40 phones, which is described as the loudness level of a pure 1 kHz tone at the loudness level at 40 dB SPL, sound pressure level. Here we have a picture that represents the family of loudness curves of pure tones in a free sound field, which are standardized. They show dependencies of sound pressure from frequencies with fixed sound loudness level. So in other words, we can determine the loudness level of a pure tone if you know frequency and sound pressure. So the equal loudness level contours are given here. So the equal loudness contour of a pure tone in free sound field. So the parameter is expressed in loudness level Ln and loudness N. And we can observe the sensitivity of human ear as a frequency, as a function of frequency. And we also can see that the most sensitive sounds, the most sensitivity to sounds around 2 to 4 kilohertz. So here, here, and here. The loudness scale, there's a relation between the loudness level Ln and the loudness N, and as a rule of thumb, we have that 2 times N is equal to Ln plus 10 phon. Here we can see different sound pressure in Pascal. This is the sound pressure level and the loudness in sonos. So for example, the threshold of pain, we have these numbers here. So in Pascal, it's 100, sound pressure level 124, and in sono 676 approximately. The auditory threshold at 2 kHz, as we've seen before, 2 times 10 to the power of minus 5 Pascal, then we have 0 dB. And for example, a TV set at home level at 1 meter distance, 2 times 10 to the power of minus 2 Pascal, circa 60 dB, and approximately 4 sona. So these are the relationships between loudness N and loudness level and loudness in general. So, and we have here these equal loudness level curves given by this picture here. We have frequency from 16 to 20 kilohertz approximately, 16 hertz to here 16 kilohertz, and sound pressure level from minus 10 to 130 dB. And we have the curves here. We have the phones, and we also have this relation about phones and sonas. That is the difference between loudness N, this psychological concept to describe the magnitude of an auditory sensation, and the loudness level, as the sound measured in phone.